Welcome to the Attack Flow training. This online training will get you up to speed with using Attack Flow even if you have no prior experience. My name is Mark Hossie, and I'm the Chief Engineer for the MITRE Center for Threat Informed Defense. Join me as we dive into all things Attack Flow. The training is split into 5 sections. In this first section, I will provide an overview of Attack Flow, why we created it, who it's for, and how to use it. The later sections will move into practical usage, demos, and hands-on activities for you to follow along with. Before we dive into Attack Flow, it will be helpful to know about our organization. The Center for Threat Informed Defense is a privately funded research and development center operated by MITRE. Our members include companies and nonprofits from around the globe and across multiple industries, including technology, retail, and finance. We pool resources, funding, and expertise from our members and use it to conduct research and development. Most importantly, we release all of our projects as open source, which includes Attack Flow. When it comes to cybersecurity, we say that it takes a village, which means that working together as cyber defenders makes us stronger and better equipped to combat sophisticated threats. Scan this QR code to learn more about our organization and how your company can join. And if you see us at a conference, come ask us for an It Takes a Village sticker. Okay, now we'll dive into Attack Flow, starting with the motivation behind the creation of this project. At the Center for Threat Informed Defense, we start every new project with what we call the PSI language, the problem, solution, and impact. For Attack Flow, the problem we are tackling is the tendency for threat informed defense to focus on adversary TTPs one at a time, which, as we will see in a moment, is a very limiting approach to cyber defense. The solution is Attack Flow, which is both a language and a tool for modeling sequences of adversary behaviors. The impact is to help both practitioners and leaders understand better how threats work and how that maps onto defensive capability. I'd like to start with a motivating example. This is a hypothetical adversary that is performing some internal reconnaissance. Our SOC analysts have observed 4 behaviors: ingress tool transfer, base 64 encoding, which is used in this hypothetical as a form of defense evasion, then PowerShell execution and port scanning. These behaviors are mapped here to MITRE ATT&CK, but using ATT&CK is not a requirement for Attack Flow. On the left side of the screen, we have the quote atomic view, which just means looking at each behavior in isolation. These techniques are difficult or impossible to defend when we consider them one at a time. For example, ingress tool transfer is really just a way of saying that a script was downloaded. It's a difficult computer science problem to determine whether a script is malicious automatically, which makes it difficult to detect this ingress tool technique. Similarly, PowerShell is a benign tool that is often used by attackers, and so again, it's difficult to determine automatically which PowerShell executions are malicious. Base 64 encoding is used for many benign purposes, so that's difficult to infer malicious intent as well. Port scanning is the most suspicious of the 4 behaviors seen here, but even port scanning might be done for legitimate reasons, such as troubleshooting network services. On the right side of the screen, we have the same 4 behaviors, only now we added arrows to indicate sequencing. That is, the PowerShell execution can't happen until the script has been ingressed and encoded, and the port scanning can't happen until PowerShell runs. This is a subtle and simple change to our view of the situation, but it gives us new ability to reason about malicious intent. For example, downloading a script and running it isn't inherently malicious, but if the script is encoded and is performing port scanning, then collectively that is very suspicious behavior. I want to point out an important concept here, and this is the most important concept in Attack Flow. The arrows in a flow do not represent chronological order. Instead, they represent a series of dependencies as the adversary works towards their ultimate goal. That is, port scanning can't take place until the PowerShell executes, and PowerShell couldn't execute until the script was encoded and ingressed. Modeling adversary behavior this way is important because we seek to disrupt these attack sequences. We are looking for choke points or specific sequences of behaviors that give us a lot of leverage for detecting and blocking the adversary. If the flow was merely chronological order, we would lose that ability. For example, the adversary has the freedom to base 64 encode the script either before or after ingressing it, which is why those both point at the PowerShell step. From a defender's point of view, we want to detect and block the attack regardless of which order those steps occurred. Okay, so that example was highly contrived. Let's look at a small but real example. This Tesla breach was reported in 2018 by security researchers from Mudlock. In this incident, attackers accessed an unsecured Kubernetes console and ran crypto mining containers. In the threat-informed defense space, we prioritize the use of threat intelligence about breaches such as this one to help us figure out how threat actors behave and whether we are equipped to prevent a breach like this one from happening in our own workplace. Cyber defenders can consume this intelligence and annotate the adversary behaviors observed in the breach, possibly mapping them to MITRE ATT&CK. On the right side of the screen, I have visualized some of these behaviors in the form of an attack navigator layer. This approach is useful for answering questions like what was the initial access vector? But it is fundamentally an atomic approach because the sequence of adversary actions is not depicted. Here's the same incident in attack flow format. The adversary behaviors that we just visualized on a navigator layer are now drawn as a flow diagram. The attack flow lets us trace through the adversary's steps and understand how each step moves them closer to their ultimate goal, which in this case is crypto mining, a form of resource theft. In the center, we have the main part of the flow, where the adversary accesses Kubernetes, creates a container, and then runs the crypto mining software. On the left side, we have the adversary setting up their crypto mining infrastructure and a couple of defense evasion techniques, such as using a Cloudflare proxy and a non-standard port. On the right side, we have another prong of the attack where the adversary has potential access to AWS secret keys. The researchers who reported this breach did not find evidence that these keys were actually used, but they did realize that the adversary might have been able to access cloud storage and exfiltrate data. Attack flow lets us assign a confidence level to each adversary action, which makes it really easy to model what we know and what we don't know in the underlying intelligence. Taken all together, the flow is a highly visual way to reason about this incident, helping us consider what choke points we might use to prevent similar attacks in the future. In prose, it's difficult to keep track of all these different threads of what the attacker is doing, and so the flow version is also easier to comprehend and less ambiguous. Now that you understand what problem attack flow is trying to solve, let's talk about what the attack flow project actually consists of. There are four main pieces in the attack flow project. The first piece is the attack flow builder, which is our web-based tool that you're going to use for creating, editing, and presenting your flows. The second piece is a flow library, which is a corpus of 34 example flows that we've constructed. And this corpus is useful for learning about attack flow, learning about publicly reported breaches, and also for data mining about historical incidents. The third component is visualization. We have a set of tools for visualizing flows in different ways, tailoring the information to different audiences and different purposes. And then the final piece of the project is the documentation. We really strive to have user-friendly documentation to introduce the concepts behind attack flow and help users get started. Underlying this entire ecosystem is a machine-readable format based on STIX 2.1, which means that attack flows are fundamentally compatible with an entire ecosystem of other STIX products. This is what the attack flow builder tool looks like. This is a browser-based tool that you use to create, edit, and present flows. You can access this tool from the attack flow project website. And it is important to know that the tool is private. When you load up your flow data into the tool, it stays local to your computer. We do not collect it or share it at any time. The flow library can also be found on the project website. This provides a list of examples where you can see information about each flow and then quickly open it up in the builder. There's also a page for visualization on our website where you can access the different visualization tools. These tools are used to either generate artifacts that are time-consuming and tedious to make, or to generate new insights about the data that you have in your flows. Last but not least, the project website includes comprehensive documentation explaining every facet of the project, why we created it, who it's for, and how to use it. And it's a great resource for those who are just learning about attack flow. Next, I want to talk a little bit about why attack flow matters, or why you should consider using it. One thing you will notice as you start to use attack flow is that this visual diagram approach is far less ambiguous than traditional prose reports. Prose tends to highlight interesting features of the intelligence and jumps around a bit, and prose is inherently limited when trying to describe multiple attack paths at the same time. Attack flow provides a clear and unambiguous picture of how an incident or campaign unfolded. Attack flow also has features to model how adversaries make decisions and how they recover from failed steps. Another reason why attack flow matters is the inherently visual nature lends itself to presenting this information to your colleagues and the leaders in your organization. It's easy to transform a flow into other visualization formats that may be more friendly for less technical audiences, or may be useful for generating insights. A third reason that attack flow is valuable is that it uses a machine-readable format based on STIX 2.1. This provides compatibility with structured threat intelligence providers and the ecosystem of tools that support sticks. For example, you can import indicators into a flow quickly or export a flow and adjust it into a compatible sort. The machine-readable format also provides integration points for others to create new solutions and features around attack flow. For example, all of our visualization tools are based on the sticks format, and for the developers out there, you can build your own tools to work with attack flow as well. Who is the intended audience for attack flow? Well, we think that there are a whole lot of roles in the cybersecurity industry that would benefit from using attack flow, but to highlight a few of these roles, first of all, attack flow is a great fit for cyber threat intelligence. You can use this to augment your CTI reporting or to replace traditional PROS reports. Attack flow has the benefits that we talked about, including automatically generating artifacts or exporting IOCs. Attack flow is also useful for incident responders who could use this to document investigations as they develop. You can use the confidence and notes features to highlight what's known versus what's unknown and where to direct the investigation next. And then we have members of CTID who use this tool for red teaming as well. They plan their red team scenarios based on known threat actors. They start at a high level and work down to a procedure level, documenting the entire thing in an attack flow format. And then after they execute the simulation, they share those notes with the blue team to debrief them. Over the past year, we've seen a huge groundswell in attack flow usage. This includes our own CTID member organizations, as well as the general public. There's a global community using attack flow from the United States to the EU to the APAC region. This ranges from large multinational corporations all the way down to small businesses and startups. And as we discussed, we're seeing usage across a lot of different cybersecurity job roles. This brings us to the end of the attack flow overview. In the next section, we'll move on to start looking at the actual concepts behind attack flow, how you read a flow, and how you start to build a flow. And then in section 3, we'll do a hands-on activity where we build a flow together. Visit our Get Involved page to learn how organizations and individuals alike can work together to advance our common goal of expanding threat-informed defense. And follow us on LinkedIn for future updates on attack flow and other major projects such as Mapping Explorer and Summiting the Pyramid.